Today, we're talking about what could be a massive leap forward for robotics. You see, a Norwegian startup called 1X has just unveiled a new AI that doesn't just learn how to do stuff, it actually imagines it first. And this could finally solve the problem that's kept truly useful robots out of our homes for decades. All right, let's get into it. Here's the game plan. We'll start with the big problem everyone's been trying to solve. Then we'll see how 1X is teaching robots just by having them watch videos. After that, we'll look at how this imagination actually becomes action, see how it performs in the real world, and finally, check out their really ambitious plan for robots that teach themselves. First up, let's talk about the fundamental roadblock that has kept useful household robots pretty much in the world of science fiction. I mean, it's a fair question, isn't it? We've got AI that can write incredible poetry, create stunning art, but getting a robot to just pick up a sock without crushing it is a whole other ballgame. That's because understanding the physical world, gravity, friction, how things squish and bend, is just unbelievably hard to code from scratch. So here's the deal. The old method, which is called vision language action, or VLA, is a huge bottleneck. These models are pretty good at connecting words to images, but they don't have a real gut-level understanding of physics. It's like they might get the command pick up the glass, but they don't intuitively know that squeezing too hard will shatter it. And that means you have to feed them tens of thousands of hours of super expensive, custom-made robot data for every single task. It's slow, it's costly, and it just doesn't scale. Okay, so that's the old way. Now let's get to how 1X is flipping this whole problem on its head with an idea that is so simple but, well, really powerful. So instead of going through all that pain of creating custom robot data, here's the big what if. What if a robot could just learn from the biggest library of how-to videos ever created? YouTube, TikTok, everything on the web. That's the light bulb moment behind this whole new model. And this is exactly why their robot, Neo, is so critical to the whole thing. Because it's shaped like a human, there's way less of a translation gap. The physics it sees in a video of a person doing something, how an object tips over or how much force you need to open a drawer, is super similar to its own reality. What it watches a human do, it has a real shot at being able to do itself. So how does this actually work? Let's break down their two-step process. Because this isn't just about mindlessly copying what it sees. This is about the robot using, well, a kind of imagination to figure out what to do. It's really a beautiful two-part system. First, you give it a command, say, put the lid on the pot. The first part, the world model, then generates a short video. It's basically imagining, okay, this is what success looks like. Then the second part, the inverse dynamics model, watches that little imaginary movie and figures out, all right, to make that happen, I need to move my arm like this and my wrist like that. So the world model is the visionary here. By watching just a ridiculous amount of internet video, it's learned the basic unwritten rules of our physical world. It doesn't just see pixels. It kind of understands cause and effect. So if it imagines pouring cereal, it knows the cereal has to fall down into the bowl, not float up to the ceiling. It can generate a future that actually makes sense. And then you have the inverse dynamics model, which is the practical engineer. It takes that vision from the world model and turns it into a concrete, step-by-step action plan. This is the crucial piece that translates the what from the video into the how for the robot's actual motors and joints. Okay, so this all sounds absolutely fantastic in theory, but the big question is always, does it actually work when the rubber meets the road? Let's take a look at the results. Now, this is where things get really mind-blowing. The robot can actually generalize what it's learned. The specific data they trained Neo on was pretty simple stuff, but because that underlying world model has learned from zillions of human videos, Neo can figure out complex things it's never been explicitly taught, like using both its hands at the same time, or even interacting with a person. And here we get a really honest look at its current skills. It's actually pretty darn good at a lot of tasks, like grabbing a bag of chips. But things that require more fine motor control, more dexterity, like pouring cereal without spilling, well, that's still a big challenge. It shows you both the incredible promise and where the tech is today. So the 1X team tried something pretty clever. Since the model can imagine what success looks like, they thought, well, what if we let it imagine a few different ways to succeed and then just pick the best looking one?
And the results are pretty striking. For a surprisingly tricky task like pulling a single tissue out of a box, just letting it think up 8 possible ways to do it and choosing the most plausible one. That boosted its success rate from 30% all the way up to 45%. It's kind of like the robot is thinking through its options before it acts.
This chart shows that the quality of the robot's imagination really depends on its training diet. It turns out that adding hundreds of hours of video from a human's first-person point of view and then using another AI to write super detailed captions, that dramatically improved how believable and realistic the robot's imagined scenarios were. And here is the real payoff. A better imagination directly translates into better performance in the real world. The models that were trained on that higher quality, more detailed data didn't just dream up better videos. They actually succeeded more often when they tried to do the tasks for real. So what's the road ahead? Well, 1X is being really transparent about the challenges they still face, but they have an incredibly ambitious vision for where this is all headed. Okay, so they've got 3 main things to work on. First, speed. Right now, it takes about 11 seconds to generate a 5-second plan, and that needs to be way faster for real-time reactions. Second, it can only plan for about 5 seconds at a time, so longer tasks will require memory. And finally, it sometimes misjudges depth, over or undershooting its target. But really, the most exciting part of their whole plan is this concept they call the self-improvement flywheel. The idea is to create robots that get smarter and smarter over time, all on their own. This is the core of it right here. As more neo-robots are out in the world, in real homes, they're constantly collecting new data from their own experiences. That data gets fed back to improve the main AI model. Then that smarter model gets pushed out to all the robots, making them even more capable. And of course, more capable robots can gather even better data, creating this powerful, accelerating, positive feedback loop. This really is their powerful, guiding vision. It's not a future where humans are endlessly programming robots. It's a future where the robot's learning is driven by its own experience, where it's constantly improving itself. And that really leaves us with a final thought. With technology like this moving so fast, it's not a question of if these robots will show up in our homes, but when. And the bigger question is, when they do, what's the one task you'd want yours to master first? Something to think about.